Hi everyone. So we are going to do the complete HVAC designing and drafting of a commercial kitchen project. So it's a fit out project in Abu Dhabi. So in this project, we are having a dining area. This one, no, it's a dining area. Like 35, 40, 41 people is there. And this is a serving area and this is a kitchen. So within this kitchen, we are having like island canopy hood. We are having one. It's a medium duty one. And here we are having a wall mount. This one is a wall mounted dishwasher hood only. This one dishwasher hood. So for this particular project in HVAC, we have to do the air conditioning first. Okay. Air conditioning we have to do first. And after that, we have to do the ventilation. Then it's a DX system. So DX split only we will be using there. I mean, ductable split AC. So we have to select the outdoor unit and the refrigerant routing we have to do. Here we have to propose a refrigerant means like a tray we have to size, pipe we have to size, routing we have to do, right? All those things one by one we can do. Initially, I'll be doing air conditioning only. Ventilation, kitchen we should keep under negative pressure because the pressure within the kitchen we have to keep comparing to the nearest area. The pressure within the kitchen we have to keep like negative so that the contaminated air or the smell, cooking smell will not be spreading to the nearest area. So like how much amount of exhaust we are taking from the kitchen? Nearly 85% we will be giving back. And the remaining 15% we will be giving to the dining and serving area. Okay, so first we can finish the air conditioning. Before doing everything, first we have to finish the heating and the cooling load calculation, right? Then only the equipment we can select. So I'll be doing this in by concept of like shop drawing, like an execution drawing. So let's start. See, first I'll be doing the heating and cooling load calculation of this hot kitchen. Then I'll be moving to the dining area and serving area. In between the dining area and serving area, we are not having a partition wall. So together we have to do it. Correct. So this is a dining area and this is a serving area. In between we are not having like RCP they have provided. So within the kitchen we have to propose square diffuser. Here we are having side throw grill only. Here we are having like a linear slot diffuser. Okay. Let's start. First, I'll be doing the heating and cooling load calculation of this one kitchen. So let me take a HAP software. I'll be doing everything in HAP only. Okay. So start a new project. So in general SI metric project latest standard, you can select which one you're having and click OK. Save this one. So I'll be saving this as, let's say, kitchen commercial. Save this one. Okay. I'm just going to the other, since this is in Abu Dhabi, so let me take the Abu Dhabi data. I'm just going to ASHRAE climate one. So 2021 latest data, I need the unit in SI. Okay, go to the stations, Asia and Abu Dhabi, UAE, Abu Dhabi International, I'll be selecting. Okay, so from here you can select annual cooling. So ventilation, when we are sizing the FAHU and all, we'll be selecting this data, evaporation. And for cooling load calculation, we'll be taking like a 0.4%. A very detailed HAP session I have already uploaded in the YouTube itself. No HAP. So I'm not repeating this because I'm directly starting. 0.4% data I'm taking, 45.1, 23. So let me keep all these things, like you can select Middle East, UAE, Abu Dhabi, and summer design DB is 45.1. And mean constant wet bulb temperature is 23. Summer daily range is 12.1. Window design dry bulb temperature, this heating condition for 99.6%, that is 12. Then winter constant wet bulb temperature we can calculate. So 99.6% heating condition, the temperature is 12, we can provide 12 there. And 99.6% humidification, the dew point temperature is coming minus 0.8. You can provide this is, yeah, same, minus 0.8, click enter. So you can see the wet bulb temperature is getting 6.2, correct. So 12, 27, minus 0.8, 12 degree, correct, 99, 12 only, minus 0.8. Okay, so 6.2. We select 12. This is 6.2. No other values I am changing. Keep it okay. Fine. Save this one. Go to the spaces. The first one I'll be doing the hot kitchen. So let me do that space first. Hot kitchen. Floor area. Let me take the floor area of this one for the measure area. This drawing we made in millimeter. So I'll be starting from here. So just go there. Ortho has to be turned on there. Then from here, the entire floor area we have to consider up to here. Okay, slight difference is coming, no issue. It's a floor area. Click enter. So this is in millimeter square. 35 meter square, right? This is millimeter square. 1, 2, 3, 4, 5, 6. 35.77. Correct. So 36 meter square. That's area. So select this one. Floor area is 36. What about the height of this one? See, those data I have already taken. We have received from the client. For the kitchen, the ceiling height means finished floor level to false ceiling level, that is coming 2.7 meter. Then finished floor level to bottom of slab 3.9 meter. So since we are having false ceiling there, 2.7 meter. Okay. Grid ceiling only we are using there, 600 by 600, 2 feet grid ceiling. That's why the square diffuser they are proposing. Okay. So that is average ceiling height is 2.7 only. Keep it medium. And outside air ventilation requirements, okay. Fresh air calculation we are doing, or exhaust calculation we are doing separately only for kitchen. So for time being, I'm not considering anything there, because based on how much exhaust we are taking from the kitchen, based on that only the fresh air we will be doing. So for kitchen, 3 equipments we required. For the kitchen air conditioning, we need a separate ductable unit. Kitchen exhaust, we need to propose an ecology unit. And kitchen fresh air, we have to propose a makeup air unit. So these 3. So when we are sizing the fresh air unit and makeup air unit, we can do that separately. We can go to the internal. Lighting details, we have not received the lighting details there. So no problem. We can go for LPD, lighting, power density. So you can go to the ASHRAE fundamentals, chapter number 18, you can take it. Okay, cooking, food preparation area, chapter number 18. Otherwise, they have also provided that one. We have received it. So this is chapter number 15, 16, 17. Keep it there, 18. Yeah. LPD value, lighting, power density. Lighting power density for food preparation, A, B, C, D, E, F. Food preparation area that is coming, 13.1 watt per meter square. Correct. Yeah, the same data I have received. Like number of people, nearly 5 numbers, lighting 13.1. So select it. This is a research unvented only. So 13.1. Velocity multiplier, keep it 1. Schedule, just 24 schedule. I don't want a very detailed schedule there. So let me make it like a 24-hour schedule. Click OK. Task lighting, there is nothing. Electrical equipment, we are having sensible there. Latent there separately. We have received this from. See, for residential, some kitchen and all will be considering like a 10 watt per meter square. Some cases, somebody will be recommending like 100 watt per meter square. Those watt per meter square assumption for kitchen will not be correct. So how much LPG that you are consuming, what all kitchen equipments we are having within the kitchen, those data we will be always getting from the kitchen supplier only, based on the equipments we are having within the hot kitchen. So from the kitchen supplier, we have received the heat gain from the kitchen equipments is nearly 6,300. So that 6,300 you can keep here. You can take it what? You can keep it here. Other you can provide, or you can provide within the miscellaneous also. Okay, so electrical, it is not mandatory to keep it exactly within the electrical equipment. You can keep it there. No, which one? Sensible as well. So I'll be placing it there. Equipment load 6,300 is coming for sensible. Latent is coming like 6.3 kilowatt. Sensible 1.3 kilowatt means 1,300 watts we are getting. Latent. Okay. Number of people is 5. And what they're doing, okay, like medium or heavy, keep it there. Now heavy work I'll be considering. Or even if medium when you're selecting, that is less. Yeah, within the kitchen, whenever the number of people are more, that much heavy activity is not mandatory. Medium work or heavy is fine. Let me take it. Go to the maximum condition, 24 hours. Fine. Okay, now we can go to the walls, windows and doors. Okay, exposure is there. Yeah, exactly. All these walls are exposing only, and this is the north side. So then it will come like south, then it is east, and this is west. So like north side, we are having an exposure. Okay. How about this one? snap settings, object snap, endpoint, the midpoint. Okay. So let me take it. The linear distance from here to here, it is coming 4.2 meter exposure. Not only that, here also we are having together, we can provide it. No need to keep it separately, or separately if you want to provide like that also you can do, because it is similar material. That's why together we can do 4.2. You can do like this 4.2 meter into 3.9 meter. Floor height is 3.9 meter only. You can see floor height is 3.9 meter. So 4.2 into 3.9, you can take north initially there. Then about this one, from here there to here, 2.7 into 3.9 meter. Again, you can take north, then you can provide like here. But instead of that, you can keep it together now, because it is exposing to the same side. So 4.2 plus, this is in millimeter only. So millimeter divided by 1000. So 4.2 plus 2.74. 2.749. So I'll be taking that as 75. 6.95 total length into the height is, you can see the height is coming in the data we are having. Floor, finished floor level to bottom of slab, 3.9 meter we are getting. So this value into 3.9. How much we are getting? 27.1 meter. Okay, select it. North exposure 27.1. So the software will be loud. Whether we are having any window there? No, we are not having any window, but we are having a door there. So this door has to be considered. And also the wall U value we have to provide. Okay, anyhow, first we can provide door. The width of door is coming, including frame, it is 1 meter. So the height will be 2.1 meter. Means our 7 feet door only, this one. So 1 meter into the height will be 2.1 meter. Correct. So 2.1 meter square area will come. 2.1 meter square. Select this one. So door, you can come there. Create new door. Let's say like north side. Door 1. Gross area is 2.1. What about the U value of door? We have already calculated the U value. How to calculate the U value? By the help of conductivity, that we have already discussed in the HAP session. So door U value for wooden door, we are getting like a 3.3 for this one. It's a 1-inch door only. Okay, so we are getting 3.3. So let me select it. The U value is getting 3.3. North side only. Fine. Keep it there. What about this wall? We have to create it. Correct. The wall U value is coming 1.85 in this case. So we have to create it. So go to create new wall. Okay. And we can start from outside surface resistance. Outside surface resistance, it's getting 0.044. Okay. Outside surface resistance is getting 0.0 outside 0.044. 0.044. And after that, we are having plaster. So keep it there. This is plaster. The R value is getting 0.02222. So the thickness is getting 16 mm. Okay. So the thickness we can provide 16.0222. Okay. Provide there. And after that, we are having a brick, a hollow brick. The thickness is 200 mm. Okay, you can provide that as 200. And the R value is 0.33. So this is coming 0.33. The next one, again 16 mm plaster. Okay. That is copy paste, Control C, Control V. This is also 16 mm, Control C, Control V. And it is coming how much? The same 0.02222. The inside surface film 0.12, resistance 0.12. See, this one we have already discussed before. 0.12. How to take this one? This data we will be taking from the material properties of fundamentals only. So those guys who missed HAP sessions can watch it. So somewhere we did mistake. Face brick, we are not having face brick there. So you can remove this one. So overall we are getting 1.857. The same only we have calculated here as well. Okay, so this is a U value of wall. You can select that one as our brick wall. Outside you can keep it medium. Okay, so 67.5% absorption. Fine. Any other we are having there? No other exposure right now. But here we are having this one, and left side also we have to take it. So north side, then this one, from here we have to take it. No, so let me snap off this one. Okay, from let's say from here to here is getting 20.2918. Okay, 2.9 meter. So 2.91 meter into 3.9 meter. It is coming 11.35 meter. 11.35 meter square. So this is north, south. This is east side only. Then this one is west. So east exposure we are having 11.35. East exposure 11.35. Any wall window? Nothing there. Okay, fine. Now this one, this side we are having. So this point you can take from here to here we are having exposure. It is coming 6.84 meter and 6.85 meter. So 6.85 into 3.9 meter, 26.7 meter square west elevation. So west elevation 26.7. Any wall, any window, nothing there? No. Okay. So I guess all the exposure, because this is partition only, both the areas are air conditioned, no need to consider this side. It is coming inside only. So exposure we have already considered. Okay. So whether this one is a brick wall, we are having a door there. No, this one. Here we are having 11 point brick wall we have assigned. This one we have assigned. Click. Okay. Okay. Here we have not assigned this one. Fine. Okay. Save this one. Fine. Now we can move to the roof. Yeah, this is exposing to that most means roof side. So roof we have to consider. This is exposing. So we need horizontal roof. There is no skylight, nothing, but a roof has to be calculated. Roof U value is coming this one 0.60. It's an insulated roof. So this one we have to create. Okay, fine. Let me select this one. Roof. Create a new roof. And the first we need roof. We can select the horizontal roof. So 36 meters square of wall area means floor area is exactly coming as the roof area. Select it, no problem. If you want to change, you can. So first outside air film 0.044. 0.044. After that plaster we are having. So you can select plaster. Plaster 16 mm. For roof as well, from the roof outside it is 16 mm plaster. And it is coming 0.02222. Okay. 0.02222. After plaster, we are having thermal insulation of 50 mm. Board insulation, keep it there like thermal insulation. The thickness is 50. R value is 1.25. R value is 1.25. Fine. After thermal insulation, we are having concrete. Like concrete thickness is how much? 150 mm. Okay, heavyweight concrete we can lightweight, heavyweight 100 mm. Let me take it. Okay. So RCC, reinforced cement concrete of 150 mm. Let me take this one 150. And the R value is coming 0.0697. 0.0697. 0.0697. We have already calculated that one. And after that, again, we are having a plaster. Whatever it may, 13 mm plywood, gypsum board, anyhow. Okay. Plaster we are having 16 mm. And it is coming 0.0222. And then inside surface film is coming 0.16. You can take 0.16. 0.638 we are hitting, 0.6376, it is rounding into 0.638. Okay, that's our default roof. It is medium in color. Click OK. Okay. Infiltration. See, kitchen, definitely infiltration will come, but the nearest areas are air conditioned. And also the air that is entering into the kitchen through infiltration is conditioned air only. Even if we are keeping like a kitchen as a negative pressure, means like for example 1000 liter per second of air we are exhausting from the kitchen, 850 liter per second we will be giving back, so 150 liter per second will be lagging within the kitchen will be under negative pressure. Contaminated air or the cooking smell will not spread from the kitchen to the outside. Even if we are keeping the kitchen under negative pressure, yes, obviously the infiltration will come, but the infiltrated air will be entering into the kitchen through the conditioned spaces only. So infiltration we can avoid, but for safety, since we are having an open door there, some like air will be entering through this open door from the atmosphere. So safety you can consider 0.5 air changes per hour. So infiltration, cooling 0.5, heating 0.5, infiltration occurs all hours. Okay. Floor, slab floor on grade only, on grade slab, correct, because the floor data, slab floor on grade only. Okay, floor U value we are having there. The floor U value is coming 3.21. This one you can provide there, floor U value 3.21. Partition, all the nearest areas are air conditioned and few areas are exposed only. So there is no partition. Let me check whether there is partition. There is a chance of partition here. Here, no, this we can, yeah, this one, the toilet we are not providing AC there. So this wall you can consider as partition. Okay, so the partition length you have to take from here to here up to here. You can internal is fine. For this case only this through this area it is coming 1.29. Let's say 1.3 meter into 3.9 meter. So 1.3 into 3.9 meter. Okay, partition 5.07. So it's a brick wall only. It's not a partition wall. So 5.07. So the partition wall partition area will be 5.07. And the partition wall, it's not partition wall, it's a brick wall only. So the U value is 1.857. So it is U value 1.857. Ambient space maximum temperature 45.1 from where? Weather data. Weather data. Ambient space 45.1 maximum, minimum 12.1. Okay, we know how to take it. I have already explained before. We can go to this one, partition 45.1 and sorry, weather data 45.1, winter design DB 12, correct, 12. So 45.1 and 12. Sorry, spaces. Partition 45.1, 12. So unconditioned space maximum temperature is 5 degrees Celsius less than this one. You can keep that as 40.1. Unconditioned space minimum temperature is 5 degrees Celsius higher than this. You can keep it 17. 12 plus 5, 17. 45.1 minus 5, 40.1. Click OK. Save this one. Okay. So if you are, if you want to check the input that you have provided, you can provide view input data and you can verify. Okay. Fine. Now I'm just going to create the system of this one, new default system. I'll be proposing, let's say, for example, like hot kitchen. I need a separate equipment for that. So I need a separate report. Equipment type, I'll be selecting terminal unit, a 2-pipe fan coil. 2-pipe fan coil. Number of zone, single zone only. Direct ventilation, common ventilation. Direct ventilation means we will be providing air exactly behind this one. Or if you're having a okay, means we'll be directly providing the fresh air exactly behind the indoor equipment. That is called a direct ventilation. There might be untempered, means like untempered means like We will not be conditioning there. Rather, instead of a fresh air fan, we will be taking the hot atmospheric air, and after that, we will be providing exactly behind the indoor equipment that it has located above the false ceiling. That is called a direct ventilation. So the equipment has to take care about the ventilation. Common ventilation means we will be having a DOIS, dedicated outside air system, a ventilation equipment, whether there is an FIHU or whatever it may, or treated fresh air handling unit or a heat recovery unit. We will be having a dedicated fresh air handling unit within the space. That machine will be conditioning the air, then we will be introducing within the space. That is called a common ventilation system. Okay. Anyhow, whether that is direct ventilation or common ventilation, in this case, we are not considering the ventilation for this indoor equipment, so you can avoid this one. Okay. Anyhow, whatever it may. So I'm just going to the zone component. Spaces, hot kitchen I am adding to the zone. Thermostat, kitchen temperature 24, definitely we need inside. Some client will be asking about 26 degrees Celsius, but here we need 24. If your requirement is 26, you can keep 26 inside. So thermostat set point, I need 24 within the kitchen. If you need to design for with the 21 degree, you can keep indoor temperature 21. Or if you want to design with the 27, you can keep 27, whatever it may. Common data. Cooling supply temperature as per the client requirement is 12 degrees Celsius in this case. Coil bypass factor is 0.15 for our design. Cooling source is not chilled water, whatever it may, doesn't matter. And we are not having any further data there. You can go to the sizing data. Cooling sensible, let's say 10% safety factor. Cooling latent 5%, heating 5%. Click OK. Okay, thermostat schedule, sorry, I have not assigned. Select it. I just need a test, means like thermostat sample schedule. Just a 24-hour schedule. So very detailed schedule that we required for analysis. And unoccupied cooling. Okay, fine. Click. Okay. Okay, so now we can check the report. Right click, print and view design result. Review. We are getting total coil load of 13.5 kilowatt. 13.5 kilowatt and nearly 680 liter per second of airflow rate we are getting. Accordingly, we have to design. Okay, so remaining data you can check there. Anyhow, that is fine. So we did this one. Now we have to do the remaining spaces. Okay, for example, we can do this dining area and this serving area. See, even though like it's a single area, means in between we are not having partition, but the airflow requirement, because we are having airflow requirement for this server area, I need separately. Airflow requirement for this area I need separately. Since we are having a separate air terminal, no linear slot diffuser there. So that's why separately we have to provide the airflow requirement there. Okay, together also you can do. For example, what you can do when you are doing it together, if you want to divide how much amount of airflow rate has to be proposed within this, no problem. We can do the heat load calculation for this one. Okay, so the total area, let's say you might be getting like 100 meters square or 130 meters square. Out of this 130 meters square, like this serving area is coming like a 30 meters square. This will be coming like 100 meters square. Okay, fine. So when we are doing the heating and the cooling load calculation together for 130 meters square, let's say we might be getting like 1200 liter per second of airflow rate. Say example. So 1200 liter per second divided by 130, you will be getting the data what liter per second per meter square. Means each meter square how much liter per second. So once we got that liter per second per meter square value, so liter per second per meter square value multiplied by 30, you can find how much amount of air will be coming within this space. Accordingly, area wise, liter per second per meter square multiplied by area, you can find the compartments, individual areas airflow rate if you are doing the heat load together. But see, since we are having the serving area, here we are having a hot pool, because the serving area, we are having what means hot water table there, a tub there. So latent heat and sensible heat will be more there in this area. So that's why we have to do this, because liter per second per meter square will not be accurate there. We are not having that much heavy electrical equipment there, but in this area we are having few more electrical equipments. No, so that's why that we need to consider a little bit extra care has to be provided. Okay, fine. So I'm doing that separately. First, I'll be doing this dining area. Okay, so take the area, go to the measure area. So from here I'll be dividing approximately from here to here, then here, then there. Okay, go up to here until here. Okay, so slight fluctuations you can avoid up to here. Click enter. It is coming 85.55 meters square. 85.6 meters square. Okay. Take it. Duplicate. Dining. 85.5. Yes, fresh air requirement we have to provide there. So we have to select the fresh air requirement for this area. Let me take it. It's a dining cafeteria or fast food. Yeah, or restaurant dining room. Keep it there. Click OK. Okay, that's area. Because we need to find the ventilation requirement for this area and this area as well. Food preparation area, this area as well. Fine. Dining area. Then internal light fixture details for dining area we have taken separately. Same, it is not, it is 2.7. Yeah, we are not having false ceiling there. Yeah, in dining area, we are not having false ceiling, I guess. Dining area, no, here, we are not having false ceiling. We got that notification, but this area we are having false ceiling, this area as well. Yeah, fine. So that's why, so average ceiling height not 2.7, 3.9 we have to provide. Dining area, we are not having false ceiling, so ceiling height should be bottom of finished floor level to bottom of slab you have to consider. No false ceiling there. But here we are having 2.7. How I know? I got after the meeting, I got the details. Lighting load is coming 7 watt per meter square. Lighting load, we are getting 7 watt per meter square. Then electrical equipment load sensible latent, okay, 4,500. And equipment load latent, okay, that is for serving area, 1,000 we are getting. Number of people, 1, 2, 3, 4, 5, 6, 6, 10, 16, 39, 40, 41, no, maximum 41 number of people. Number of people, yeah, 41 numbers. So within dining area, we are having 41 number of people. Like sedentary or seated assist, you can consider like sedentary, you can select. Okay. Walls, windows, exposure area. Exposure horizontal, the area is coming 85.5. So this is 85.5. Infiltration 0. We don't want that because it's a positively pressurized area. Partition heat transfer, yes, all these wall you have to consider as partition. No need to segregate wall and door separately. So I'm taking a poly line from here to here. Together I'll be taking from here to here, here to here. This one, this entire length we are having partition walls. Correct. All these are partition wall exposure only. From this is an exposure from here. No, see all these. This side we will be having exposure. Heat will be entering. This is an exposure. 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 So even though we are having a door there, the U value will be slightly different than door, but it is negligible. It is not a huge issue. So together I am just providing it. The total length of partition wall is coming because toilet is an unconditioned space only. So list enter, LI enter, we are getting a length of 9.67 meter. Correct. So this one, okay, LI enter, list enter, 9.67. So 9.67 into the height is 3.9. We are getting 37.7 meter square. The same U value you can keep 37.7. All partition 37.7. Rest everything is same only. Click OK. Okay. Save this one. Fine. Okay. See, for when we are providing the input for this one, for example, if you are having like a 41 number of people there, 41 whenever it is fully filled, 41 meals can come. Each meals will be coming like 15 watts of load. Out of this 15 watt, 75 sensible and 25 watt means 25% will be latent. The same way, here we will be having a serving table, no, warmer table. No, this is a warmer one. So like normally like in this case, no, here we will be having both sensible and latent. So those data, if you are not getting from the kitchen supplier, We can take it from ASHRAE fundamental as well, approximately. Okay, if you are going to the chapter number 18 of ASHRAE fundamentals, table number 5A of chapter number 18, here you can see like foot warmer steam table. The rated load is like a 2-well type. Sometimes it might be 3-well or 4-well, means the bowls that we are having might be more. For 2-well type, the standby load will be this one. Average heat gain, total heat gain will be 1026. Out of this 1026 watt, 762 will be latent, then 88 plus 176. 88 will be radiant and convective. That is fine, but both are sensible only. So 176 plus 88, how much you are getting? That will be sensible. 762 will be latent for 2-well. But anyhow, our case, we have received it. We have received all this data because this meal data. No? Meal data also they have provided. For example, here you can see heat gain from meals. For each meal served, approximately 15 watt of heat, of which 75% is sensible. So for example, if you are having like a 41 number of people, so 41 into 15, correct. This is a total heat gain from meals. 75% of this one, 0.75. 461 will be sensible, remaining will be latent. Like that also you can consider it. But anyhow, the data that we have received here, no, that we have calculated, that is including the sensible and latent, that is including the meal load only. And the equipment load that we are having in the serving area, this we have received both latent and sensible separately from the supplier. So I'm not taking any approximate data since we are having the actual data. Okay. So if we have not received this data, I will be taking this data from the ASHRAE fundamentals. Just for your knowledge, I told. Fine. Okay. Now I am just doing this one.